Hi everyone, we're solving this math paper today. This is 9709, paper 13, the last one in the May-June 2023 series. So before we begin, let's take a look at the threshold. But before that, I just want to give a quick shout out to my Patreon. It's patreon.com/CIE paper solved. As you can see, there are three tiers, one for general support. There's another one for notes and paper solving requests, where you get access to ad-free videos as well as chapter-wise notes for physics and chemistry, and solved papers for math P1, P3, S1, M1, as well as physics, chemistry, and bio, paper 1, paper 2, paper 4, and paper 5. So it's an offer that you can't refuse, honestly, as well as the last year, the Ultimate Learning Experience, where you get access to one-on-one video calls with me once or twice a month, and access to some private videos on particular topics, and your name in the credits on screen on all of my YouTube videos for as long as you support me. Anyway, let's begin. So let's take a look at the threshold. Um, For paper 1-3, out of 75 marks, A was at 62. So this is a comparatively easier paper compared to the other two, which were much harder. B was at 53, C was at 40, D was at 28, and E was at 16. All right. So let's just write that down. Out of a total of 75 marks, here we go. A, B, C, D, and E. A was at 62. B was at 53, C was at 40, D was at 28, and E was at 16. So A star should be at, if you look at the mark difference, it's 13 here, it's around 9, it's around 12 here. So yeah, A star was pretty high. It will probably be at around 70, probably. That's what it looks like, because as you can see, the difference is too high. See, the difference is 12, 13, or 9. So yeah, it might be 74, 72 as not 74, that's too high. Around 70 basically for A star. So you have to do really well in this paper to score, an A star. So honestly speaking, easier papers are harder to get an A star at. Anyway, the total mark for this paper is 75, and all answers are to be given to 3SF or one decimal place, 4 angles in degrees. Otherwise, like unless a different level of accuracy is specified in the question. Anyway, guys, if you do like my math content, please drop a like and hit the subscribe button. It helps with the algorithm a lot. Also, please do comment below if you have any other requests. And good luck for your paper if you're giving the exam in this October-November 2023 session. I think it's on the 11th of October. So if you do have other queries, please hit me up. We also have launched our Discord channel, so please consider joining there so that you can, post your problems. If I'm free, I'll just check them out whenever I can. Okay, so without further ado, let's begin. Starting with question number 1. Okay, what do we have here? The diagram shows the graph of y equals to fx and y is equal to gx. Y equals to fx consists of two straight lines, AB and BC. It's the one on the left hand side. The lines a prime, b prime, and b prime, c prime form the graph of y is equal to gx, which is the result of applying a sequence of two transformations in either order to y is equal to fx. Fine. So the order doesn't matter. We want to go here basically. So essentially, as you can see, it is a stretch and a translation, clearly. Why is it a stretch? Because, hear me out, check this. Before, the width of this was one box. Now the width has turned into two boxes. Similarly, this width was two boxes from B to C. Now it has turned into four boxes. So clearly it's a horizontal stretch, right? Clearly it's a horizontal stretch with stretch factor 2. Every value that is on the x-axis will become double its initial value. So you see this 2 over here? The y value will remain unchanged. So b will remain at 5. It's just that this 2 will become doubled and it will move on to 4. Okay, similarly, this a over here, it's at 1, it will be doubled and it will move on to 2. And this c, which is at 4, 4 times 2 is actually 8. So this is our graph over here after we apply the stretch. Okay, and now what? As you know, I just told you that there is also a translation. So that moves our point B 2 units downwards. 1 unit over here, then the second unit down here. Okay, so 2 units in total. So that's a translation of 0 and minus 2 since it's vertical. Okay, so it can be done in any order. Honestly, I'm just gonna go for the stretch first. So stretch with scale factor 2, which is horizontal or which is parallel to the x-axis. That's how they wrote it. So that's one, and followed by a translation with vector. What is the vector? It's 0 minus 2. So that is it for our answer. Okay, makes sense? Fine, let's move on to question number 2. The function f is defined for the domain all real values of x by, what do we have? It is fx equals to x squared minus 6x plus c, where c is a constant. It is given that fx is greater than 2 for all real values of x. Fine. So, you know, the minimum value, right? It has to be greater than 2, essentially. So, we can actually solve this by completing the squares. So, let's try to do that. Or you can also differentiate it. Okay, there are multiple ways to do it. So, for example, if I complete the squares, what do I get? X squared minus 2 times x times 3. So we get plus 3 square minus 3 square plus c. So we ultimately end up with x minus 3 whole square, right? Minus 9 plus c. So this is fx after completing the squares. Now it is known that the value of fx, right, it is always greater than 2 for all values of x over here. Okay, so how do we solve this? So essentially the whole of fx is greater than 2, so we can actually write that x minus 3 whole square minus 9 plus c is greater than 2, or x minus 3 whole square plus c is greater than 2 plus 9, which is 11. Finally, what do we have? C is greater than 11 minus x minus 3 whole square. So this is what we get. Now the mark scheme actually did it in a really weird way. They wrote like this: x minus 3 whole square is greater than or equal to 0. We do know that, but when does fx take its minimum value? Because this is a minimum function, right? Since x squared has a positive number multiplied with it plus 1. So we know that basically I'll show you a few ways to do it. Basically, if x takes its maximum value of minus 9 plus 2, sorry, minus 9 plus c, the minimum value, right? Minimum value of fx equals to minus 9 plus c when x is equal to 3. So if you input 3 over here, what are you getting? C is greater than 11 minus 3 minus 3 whole square. So c is greater than 11. This is what you're getting. Okay. Or there was another way to do it. Basically, from this step over here, you could just say that the minimum value is equal to minus plus c, and we know that our value of fx, right, it is greater than 2. So we can say that the minimum value is approximately, the minimum value of fx is greater than 2. That is for sure. So I can just equate this. minus 9 plus c is greater than 2. Therefore, c is greater than 2 plus 9, which is 11. That is also another way to do it. Okay. So essentially, you guys need to know that uh, fx will take its minimum value when x is equal to 3. So if you input that over here, you are getting the minimum range set of values for c. Or you could just equate the minimum value, which is minus 9 plus c, equate the minimum value of fx with this greater than 2. It has to be greater than 2, right? The minimum value. As a result, we end up with this. So what are other ways we could do this? Basically, there's another method. Let me show you. By calculating, by differentiating the function by calculus. If you differentiate x squared minus 6x plus c, you actually get 2x minus 6. Now if you equate that with 0, we are actually getting the value of x is equal to 3. This is what we get. So this is the value of x where fx will take its minimum value. So now what? In fx is equal to x squared minus 6x plus c, you can actually input the value of x3. What are you getting? It's 9 minus 18 plus c, which is minus 9 plus c at f3. And we know that this is our minimum value, so we can say that our minimum value needs to be greater than 2. Therefore, c needs to be greater than 11. Honestly, I prefer this method. It's the same thing I showed you here. It's just that they wrote that in a weird way in the mark scheme, honestly. Now let's go to question number 3. Give the complete expansion of this. Okay, so x plus 2 by x to the power 5 is equal to x to the power 5, 5c0 x to the power 5 plus 5c1 x to the power 4 into 2 by x plus 5c2 x cube 2 by x whole square plus 5c3 x square 2 by x whole cube plus 5c4 x to the power 1 2 by x to the power 4 plus 5c5 x to the power 0 and 2 by x to the power 5. That's the final one. So let's write it down. X to the power 5 plus 5c1, which is 5 times 2, 10 times x cube, x4 minus 1 is 3, then 5c2 into 2 square, which is 40, plus 40 x cube by square, which is just x, then 5c3 into x square into 2 cube divided by x cube, so x square by 3. What is it? X to the power minus 1, right? So that is going to be plus 80 times x to the power minus 1. Then 5c4 into 2 to the power 4, that is also 80. So plus 80, how much is it? X to the power 1 by 4, which is x to the power minus 3. Then 5c5 into 2 to the power 5, which is 32. Plus 32 into x to the power minus 5. That is our complete expansion, okay? X to the power 5 plus 10x cubed plus 40x plus 80x to the power minus 1 plus 80x to the power minus 3 plus 32x to the power minus 5. Okay, moving on. In the expansion of a plus bx square times x plus 2 by x to the power 5, the coefficient of x is 0 and the coefficient of 1 by x is 80. Find the values of the constants a and b. Okay, so it can be written that a plus bx square times this expansion that we just found out. Wait, let me just copy paste this. Here you go. Right, so this, for this, the coefficient of x is 0 and the coefficient of 1 by x is 80. So how do we get the coefficient of x actually? A times this over here, a times 40. A times 40, that is 1. This is one coefficient of x. This times this one over here. Similarly, if you multiply bx square with this one, plus if you multiply bx square with 80x to the power minus 1, b times 80, that gives you the coefficient of x, which happens to be 0. So we can write 40a plus 80b equals to 0, or a plus 2b equals to 0. That is one of them. Now what about the other one? The coefficient of 1 by x. How do I get that? Like if you multiply a with this over here, this is the coefficient of x and this is the coefficient of x to the power minus 1. So a times 80, okay, and what do you multiply x squared with? X squared with x to the power minus 3, right? Bx squared times 80x to the power minus 3. Because 2 minus 3 is minus 1, so that is plus b times 80, that gives you the coefficient of x to the power minus 1, which is equal to 80 itself. The coefficient is equal to 80. So 80a plus 80b is equal to 80 as well. So that gives us a plus b is equal to 1. Interesting. So let's solve this now. We know that a is equal to 1 minus b. So if you input that over here, 1 minus b plus 2b equals to 0. B is equal to minus 1. And similarly, a is equal to 1 minus minus 1. So a is actually equal to 2. So that is the answer. Fine. That matched. Quite tricky for a P1 sum because you need to know how to multiply everything over here. Anyway, question number 4. Show that the equation may be expressed in the form a cos to the power 4x plus b cos square x plus c. Okay. So we have 3 tan square x. 3 tan square x minus 3 sine square x minus 4 equals to 0. 3 tan square x can be written as 3 sine square x by cos square x minus 3 sine square x minus 4 equals to 0. So after, simplification, we end up with 3 sine square x minus, because the LCM is actually cos square x. If you perform this step over here, the LCM is actually cos square x. So 3 sine square x minus 3 sine square x cos square x minus 4 cos square x is in fact equal to 0. So after further simplification, 3 sine square x minus 3 sine square x cos square x minus 4 cos square x is equal to 0. Now as you can see in this equation, we have no sine square left anymore. So what can we do? You guys know that sine square x equals to 1 minus cos square x, that is given in the formula sheet. So I'm just gonna apply this substitution. 1 minus cos square x minus 3 1 minus cos square x times cos square x minus 4 cos square x equals to 0. So that is 3 minus 3 cos square x minus 3 minus 3 cos square x times cos square x minus 4 cos square x equals to 0. After further simplification, that is 3 minus 3 cos square x minus, I'm multiplying them, okay, this and this, minus 3 cos square x and minus minus plus 3 cos to the power 4x minus 4 cos square x equals to 0. Now after the final simplification, what do we end up with? It is actually 3 cos to the power 4x and minus 4 minus 3 minus 3, that is minus 10 cos square x plus 3 is equal to 0. So this is my final answer. 3 cos to the power 4x minus 10 cos square x plus 3 is equal to 0. Okay. So A is 3, B is minus 10, and C is 3. Hence solve this equation. Fine. So we have 3 tan square x minus 3 sine square x minus 4 equals to 0. We can write this as 3 cos to the power 4x minus 10 cos square x plus 3 equals to 0. Now we can even do this. Let cos square x be a, right? So 3a square minus 10a plus 3, right? Plus 3 equals to 0. So after you perform middle term breaking, 3 minus 10, 3, we actually end up with this. One of them is a minus 3 and the other is 3a minus 1. 3a minus 1 equals to 0. I did it using the calculator. So a is equal to 3 and on the other hand a is equal to plus 1 by 3. Or cos square x equals to 3 and cos square x equals to plus 1 by 3. So now what? The domain is fixed at 0 to 180 degree. So one of them is cos x equals to plus root 3. Then we have cos x equals to minus root 3. And what else over here? We have, do I have more space down here? No, I don't. Cos x equals to plus 1 by root 3 and cos x equals to minus 1 by root 3. Now let's do the cos inverse. We have to put this in degrees, by the way. So in degrees, cos inverse of root 3, it is not applicable, and cos inverse of minus root 3 is probably not applicable as well. So these are not possible. So similarly, cos inverse of 1 by root 3 is actually alpha equals to 54.7 degree and minus 54.7 degrees. On the other hand, cos inverse of minus 1 by root 3 is equal to 125 degree. Alpha equals to 125.3 degrees and minus 125.3 degree. So therefore, according to my domain over here, my final answers are therefore x equals to 54.7 degrees and 125.3 degrees. I am only going to go with these two answers. Yes, those are the final answers. Good. Moving on to question number 5. How many do we have in total for this paper? Wait, let me just check. We have a total of 10. Okay, so we are currently at 5. Hopefully we're going to be done in 1 hour. A circle has equation this aligned with equation x minus 9 intersects the circle at a and b. Find the points of intersection. Okay, so we have y is equal to x minus 9 and x minus y whole square plus y plus 4 whole square equals to 40. So let's try to just input this. X minus 1 whole square plus x minus 9 plus 4 whole square is equal to 40. So let's just break it down. X square minus 2x plus 1 plus x minus 5 whole square equals to 40, and then x square minus 2x plus 1 plus x square minus 10x plus 25 is equal to 40. So we have 2x square minus 12x plus 26 is equal to 40. And finally, twice x square minus 12x minus 14 is equal to 0. Okay, so we can simplify this further, which is x square minus 6x minus 7 equals to 0. Now, if you use your calculator to solve this, you are getting 1 minus 6 and minus 7. So yeah, I get x equals to 7 and minus 1. But you can't write that directly, you just have to show another step. X equals to 7, so x minus 7 and x plus 1 equals to 0. So therefore x equals to 7 and minus 1. Now they want the coordinates, not the x coordinate only. So we know that y is equal to x minus 9. So y equals to 7 minus 9, which is y equals to minus 2. And y is equal to, what was that? Minus 1. Minus 1 minus 9, so y is equal to minus 10. Okay, so our final answers are 7 and minus 2. And then we have minus 1 and minus 10. That is all. Let's check. Yeah, that's the correct answer. Now find an equation of the circle. Find an equation of the circle with diameter AB. So these are our points A and B, or vice versa. Now we need to find the midpoint first. So let's find out the midpoint of AB. So in the mark scheme, they consider the midpoint to be C. C is the midpoint. It doesn't matter, you can just take any point of AB, right? Which is 7 minus 1 by 2 minus 2 minus 10 by 2, which is 6 by 2 and minus 12 by 2, or 3 and minus 6. So this is our midpoint. Now we have our midpoint, we just need the radius. Okay, so let's find out the radius. It's pretty simple. It is root over, I just take one of these points, maybe I take 7 and minus 2. So that's 7 minus 3 whole square plus minus 2 plus 6 whole square, which is root over 4 square plus 4 square, which is 16 plus 16, root over 32. So can I use my calculator to simplify that? Yeah, it's 4 root 2 actually. Or just keep it as 32. Root 32, it's fine because we're going to square it anyway. So let's write down the equation of the circle, which is pretty straightforward. That is let's start with x, my bad. X minus 3, remember that the coordinates get inversed. X minus 3 whole square plus y plus 6 whole square is equal to root 32 whole square, which is 32. So let's match with the mark scheme. X minus 3 whole square plus y plus 6 whole square equals to 32. Fine. Moving on to the last 5 questions. Question 6, the diagram shows a sector OAB of a circle with center O and radius R. Angle AOB is equal to theta radians. It is given that the length of the arc AB is 9.6 centimeter and that the area of sector OAB is 76.8 centimeters square. Find the area of the shaded region. Fine. It's pretty straightforward, honestly. We have the arc length that is equal to 9.6. The sector area is 76.8 centimeters square. So what can we write? We can go for S equals to R theta. So arc length 9.6 is equal to R theta. Also the area equals to half R square theta, which is 76.8 is equal to half into R square into theta. That is 76.8 into 2. It's 153.6. 153.6 is equal to R square theta. So can we do this? 153.6 equals to R times R theta. Now we know that R theta is equal to 9.6. So 153.6 is equal to R times 9.6. So 153.6 divided by 9.6. That means R is equal to 16. That is our answer. R is equal to 16 centimeters. Now, what about theta? We know that 16 times theta is equal to 9.6. 9.6 by 16, the 0.6. Theta is equal to 0.6 radians. Fine, that's good. Now, what do we need? We need the area of the shaded region, which is sector minus triangle. Pretty straightforward. Area of shaded region is equal to area of sector minus area of triangle, which is equal to 76.8 minus area of triangle half AB sine theta, or 76.8 minus half into AB, which is 16 into 16 into sine 0.6. So let's do this. 0.5 into 16 into 16 into sine 0.6. Oh, my calculator has to be in radians, by the way, or else it won't work. So yeah, this value over here, it's actually 76.8 minus 72.27. So 76.8 minus answer gives you a value of 4.52 to 3 SF. 4.52, sorry, to 3 SF, 4.5257. So if you round it off, it's actually 4.53 centimeters square to 3 significant figures. Okay, so be careful about that. It's very important that you follow the rules. You have to round it off and give your answer to 3 significant figures. I hope that makes sense to you guys. Okay, now find the perimeter of the shaded region. So what do we have for the perimeter? The arc length and this line over here. So how to find out this line? Essentially, you can divide this triangle into 2 equal parts, 2 right angle triangles. So yeah, this is theta by 2, or 0.3 rad. You have R and this is a right angle triangle. You can actually find out this length and then multiply it by 2. So let's call that length AB by 2, or we can just call it X. Okay, according to my diagram it's X. So I'm just going to use trigonometry. Sine theta, sine 0.3 I mean, is equal to opposite by hypotenuse. So sine 0.3 is equal to opposite X by hypotenuse R. So X is actually equal to 16 times sine 0.3. And what about AB? AB is equal to twice X. So that is 2 times 16 times sine point 3, 2 times 16 times sine point 3, that is 9.457. Okay, so what about the perimeter? It is basically this length, 9.457, plus, you know, the arc length, which is 9.6 centimeters, plus 9.6. That is giving you a value of 19.06. So if you round it off, that's 19.1 centimeter, and that is your answer. Okay, that's very good. We can move on to the next one now, number 7. So the function f is defined as fx equals to 2 minus 5 by x by 2 for x is greater than minus 2. State the range of f. Okay, so it's best if you honestly draw the graph. It's much easier. So check this out. At minus 2, the graph doesn't exist because it becomes 5 by 0, which is not possible. Okay, so what about next? What about x equals to minus 1? So 5 divided by, I'll just write the equation in my calculator. 2 minus 5 by, where's x? One sec. 5 by x plus 2. So calc, if you use minus 1, what do you get? Minus 3. At minus 1, it is 1, 2, 3 over here, minus 3. And then at x0, it is minus 0.5. At x0, it's minus 0.5 somewhere over here. And then at x 1, it is 1 by 3. At x1, it is 1 by 3. So this is 1, 2, 3. 1 by 3 is somewhere over here, or even lower. Then at 2, it is 3 by 4. At 2, it is 3 by 4. Calc 3, it is 1. At 1 to 3, it is 1. Now we can just go for a really high value. At 1000, it is 1.995. Okay, at 1000, it's 1.995. So basically, it never reaches plus 2. That is essentially the gist. Because if you try calc 4, it's still 7.6. Basically, the graph is going to be like this. It will never touch this line over here. So it increases like this onwards, and it never touches this line over here. Okay, so this is your graph. So for x greater than minus 2, what is the range of f? Essentially, f goes to minus infinity over here, and at the top it can never exceed 2. So it is always, right, it is always less than 2, because 2 is an asymptote plus 2. So we can write fx is always less than 2. So it's best if you always draw graphs for this. Okay, obtain an expression for f inverse and state the domain of f inverse. So the domain of f inverse will be the range of fx, right? So let's go for it. Let fx be y, so we can write y is equal to 2 minus 5 divided by x plus 2. So that is actually equal to, wait, 5 divided by x plus 2 is equal to 2 minus y. Then 5 is equal to 2 minus y times x plus 2. Then 5 is equal to 2x plus 4 minus xy minus 2y. So who do we need to make the subject again? X, right? So we get 2x minus xy is equal to 5 minus 4 plus 2y. And finally, after you take x, 2 minus y is equal to 1 plus 2y, or x is equal to 1 plus 2y by 2 minus y. So finally, therefore, f inverse x is equal to 1 plus 2x divided by 2 minus x, and our domain is going to be this range. Okay, so the domain is going to be less than 2. That is our answer. Domain is less than 2, and the f inverse x is 2x plus 1 divided by 2 minus x. I get why this paper was easier compared to the other ones. Those ones became progressively harder, but for this particular question, the relatively harder ones compared to these ones were at the beginning instead. Yeah. Okay, so we are good to go to the next one. Part C, the function g is defined by gx is equal to x plus 3 for x is greater than 3. Obtain an expression for f gx, giving your answer in the form ax plus b divided by cx plus d, where a, b, c, and d are integers. Okay, so gx is equal to x plus 3 for x is greater than 0. And if gx, let's find that out. What is fx? 2 minus 5 divided by x plus 2. 2 minus, God, 2 minus 5 divided by x plus 2. Fine. Now, how do we solve this? Basically, for fgx, okay, for fgx, what do you need to do? You need to input the one that is outside, the one that is inside, okay? The one that is inside, you need to input that to the one that is outside. So you need to input g inside f. So let's try to do that. I'm going to input g into f. So that is going to be 2 minus 5 divided by, so g is going to be here in the position of this x. X plus 3 plus 2. So if we simplify it further on, f gx is equal to 2 minus 5 divided by x plus 5. So this is it for f gx. Now they want us to give it in this form, and sometimes they might want the domain and range of this. So what's important is that if you look at the two domains, okay, for gx it is x is greater than 0, and for fx the domain is x is greater than minus 2. So for it to be valid, okay, the domain of gx must be within the domain of fx. Okay, the domain of the one that you are inserting has to be within the domain of the one that is, well, let me word it another way. The domain of the function that you are inserting has to be within the domain of the function that is, outside fx here currently. Okay, so since we're inserting gx into fx, the domain of gx must be satisfied by the domain of fx. That's what I wanted to say. Okay, and how would you solve it? So this gets priority for, so what is happening currently? Like, how would you find out the domain? Okay, let me simplify this first, then I'll teach you. So what's the next step? If gx is equal to, after LCM, that's twice x plus 10 minus 5, or if gx is equal to twice x plus 5 divided by x plus 5. So this is it. This is what we needed to write. This is our final answer. But I do want to teach you how we find out the domain and range actually. So I told you what gets priority, right? Basically, for it to be valid, since we are inserting gx into fx, the domain of uh, gx must be within the domain of fx. That's the first criteria. So if we draw the number line, -2, -1, 0, 1, 2. Now x is greater than 0. This is for gx, and for fx, it is x is greater than -2. So look at this. Gx does fall within the domain of fx, so it's fine. It's okay. But the other way around wouldn't be alright. We could not form gfx, but we can form fgx. Next, if you take a closer look at this, what has happened? Basically, the place of this x over here, okay, the one that satisfies this, has been taken by gx. Gx has hijacked this spot over here, this x over here. So if you ever want to find out the domain, what you guys need to do is, basically, when you input this over here, since gx has taken the spot of this, it's now gx is greater than -2, or x plus 3 is greater than -2, or x is greater than -5. This is now the new domain for fgx. Sometimes they ask you to find this, okay? So this is something that you guys need to know properly. Hopefully you guys understood. And yeah, I have also solved other papers where this concept was applied. Anyway, moving on to 8, 8, 9, 10, last three. I'm going to be done within 20 minutes. A progression has first term a and second term a squared divided by a plus 2, where a is a positive constant. For the case where the progression is geometric and the sum to infinity is 264, find the value of a. Okay, it's a geometric progression. So the first term is a. Just say that t1, term 1 is equal to a, and term 2 is equal to a squared by a plus 2. So r can be written as term 2 by term 1, which is a squared divided by a plus 2, the whole thing divided by a. So afterwards, what do we get? R is equal to a squared divided by a times a plus 2. So that's that. Now, for the case where the progression is geometric and the sum to infinity is 264. So what is the formula for sum to infinity? It's given in the data booklet by, but I haven't memorized the data booklet MF19, right? So I actually have it memorized. So what is it actually? As you can see, it's a divided by 1 minus r. So if you input this over here, the sum to infinity is 264 actually. So 264 is equal to um, a divided by 1 minus r, which is 1 minus a square divided by a into a plus 2. So after further simplification, what do we get? 264 is equal to a divided by, after LCM, right? I'm going to apply LCM over here. A times a plus 2, and over here it is a times a plus 2 minus a square. So after LCM and reciprocal, we actually end up with it's a multiplied or divided by this. So after reciprocal, the denominator is going to come up, right? So that's a times a plus 2 divided by a square plus 2a minus a square. So finally, what do we get? We can get rid of these a squares, and at the top we end up with a square times a plus 2 divided by 2a. So after cross multiplication, what is 264 times 2? That is 528. So 528a is equal to 528a is equal to a cube plus 2a square. And after further simplification, a cube plus 2a square minus 528a is equal to 0. Now you can actually take a common. So a square plus 2a minus 528 is equal to 0. So this is our final step. What do they want actually? Find the value of a, and it's given that a is positive. Okay, so a cannot be 0 because a is positive. So we ultimately end up with a square plus 2a minus 528 is equal to 0. So after middle term breaking, 1 2 minus 528, I'm getting this a minus 22. A is 22, that's one answer, and the other is minus 24. So a plus 24, this is the middle term breaking, equals to 0. Therefore a is equal to plus 22, that is my answer, and a cannot be equal to minus 24. Okay, and finally we are done. So a is equal to plus 22 only, and all the other answers are rejected. Is that fine? Okay. For the case where the progression is arithmetic and a is equal to 6, find the least value of n required for the sum of the first n terms to be less than 480 minus 480. Okay, so a is equal to 6. So t1 is equal to 6 and t2 is equal to, what was it again? A square divided by a plus 2. This part is valid for both parts, okay, A and b. A square divided by a plus 2. 36 divided by 6 plus 2, which is 8. That is 4.5. T2 is equal to 4.5. So we know that Tn is equal to a plus n minus 1d. So we can actually write T2 is equal to a 6 plus 2 minus 1 times d. So T2, which is 4.5, 4.5 equals to 6 plus d. So 4.5 minus 6, that is minus 1.5. D is equal to minus 1.5. That is our common difference. Now we want the value of n. We need the least value of n for the sum of the first 10 terms to be less than minus 480. So we want Sn to be less than minus 480. Now the formula for Sn is n by 2 followed by 2a plus n minus 1d. That is the formula. Okay, that is also given in the formula sheet. Here you go. So where is the sum? Arithmetic series. The sum is half into n, 2a plus n minus 1d. Okay. Now let's just input this. N by 2, 2a, which is 2 times 6, 12, plus n minus 1. D is actually equal to minus 1.5, is less than minus 480. Fine. So let's do or complete the working, shall we? Okay, so n by 2, 12 minus 1.5 n plus 1.5 is less than minus 480. That is equal to n by 2, 12 plus 1.5, 13.5 minus 1.5 n is less than minus 480. Okay, so after cross multiplication, 480 times 2 is 960 actually. So n 13.5 minus 1.5 n is less than minus 960, or 13.5 n minus 1.5 n square is less than minus 960. And therefore, finally, therefore, if you move everything to the right, okay, 0 is less than minus 960 plus 1.5 n square minus 13.5 n, or if I just bring it to this side, 1.5 n square minus 13.5 n minus 960 is actually greater than 0. Now to solve this, actually we should make it a bit simpler. We should multiply, or I think we can divide everything by 1.5. 13.5 by 1.5 is 9. Yeah, if I divide everything by 1.5 over here, I actually get n square minus 9n, and 960 by 1.5 is 640. Minus 640 is greater than 0. Now if you try to input this in your calculator, 1 minus 9 minus 640, you actually get the answer in decimals. So we can't really solve the middle term breaking in any way. So what should you do in cases like this? Typically, we should opt for using the general formula. Okay, so let's use the general formula from this step onwards to find out the critical values. Okay, to find out the critical values, what do we do? N is equal to minus b, which is minus minus 9, plus minus root over b square minus 9 square minus 4ac, 1 times minus 640, divided by 2a, 2 into 1. So n is equal to plus 9 plus minus root over 81 plus 4 times 640, which is 2560, divided by 2. So that's huge. 81 plus 2560. If you write this step, that's more than enough. So 81 plus 2560, root of answer. Yeah, so we actually get n is equal to 9 plus minus root over 81 plus 2560, 2641 by 2. So what are our two answers? 9 plus root over 2641 by 2, which is the critical value. So the critical value, if we just put this a bit higher up. So the critical value of n, one of them is 30.2, the other is 9 minus root over 2641 by 2, which is minus 21.2. Now, look at this. This is a minimum curve, right? So where do they intersect? One of them is at 30.2, the other is at minus 21.2. So it's going to look like this, the minimum curve. I am targeting it to be greater than 0. Okay. So basically it is n is either greater than 30.2 or n is less than minus 21.2. However, n can't really be a negative value. N has to be an integer and a positive value. Therefore, the only value of n is a value which is greater than 30.2, and the first integer is 31, and that is my answer. Okay, so see if you guys get this. All right, that is perfect. Okay, let's move on to the next one. For a second there, I just felt like Homelander. You know the It's Perfect meme? I was just thinking of that. Have you guys watched The Boys, by the way? It's an insane series. Anyway, I'm waiting for the next season. Anyway, for question number 9, last two, a curve passes through 0, 3 and has the equation y equals to fx. It is given that f prime x is equal to this. Find the equation of the curve. Pretty straightforward. We know that since f prime x equals to 1 minus 2 divided by x minus 1 cube, we can find out fx. That is basically the integral of f inverse x dx. Fine. So let's do this. If you integrate it, what do you get? X. This can be written as, 1 minus 2 x minus 1 to the power minus 3. It can be written as x minus 2 x minus 1 to the power minus 2 divided by the new power will go down multiplied by 1 plus c. So finally we end up with fx equals to x plus, we can get rid of these 2's, 1 divided by x minus 1 whole square plus c. Now we have the coordinates of 0, 3 over here, right? It's 0, 3. So if you input that over here, you know that fx is equal to 3 when x equals to 0 plus 1 divided by 0 minus 1 whole square plus c. So 3 is equal to 0 plus 1 divided by minus 1 whole square plus c. 3 is equal to 1 plus c, or c is equal to 2. Fine, fine, fine. So what is the equation of the curve? If x equals to x plus 1 divided by x minus 1 whole square plus 2. So we found out the equation of the curve. X plus 1 divided by x minus 1 whole square, or x minus 1 to the power minus 2 plus 2. Next, the tangent to the curve at 0, 3 intersects the curve again at another point P. Show that the x coordinate of P satisfies this equation. Fine. So what is the f prime x, or dy by dx, is this equation over here. Check it out. F prime x is this equation over here. So honestly speaking, we know that when I input 0 over here, the gradient will be equal to 1 minus 2 divided by 0 minus 1 cube, which is 1 minus 2 divided by minus 1 cube. That is 1 minus 2 divided by minus 1, or 1 plus 2, which is 3. Fine. Now we have to find out the equation of the tangent at this point. Okay, so how do we do that? It's basically y minus y1, y minus y1, which is 3, is equal to the gradient 3x minus x1, which is 0. So y minus 3 is equal to thrice x, or y is equal to 3x plus 3. So this is the equation of my tangent over here. Now this tangent will intersect the curve again. So what's the equation of the curve that I just found out? It's this. My tangent, suppose this is a curve, right? Suppose this is a curve, and we found out the equation of the tangent at this point. Maybe it's just a bit more curved like this. Here you go. Okay, so we just found out the equation of the tangent at a certain point, and it's like it's gonna intersect. Wait, I'm drawing the wrong figure. Maybe it's a curve like this. Okay, fine, check this. Maybe it's a curve like this. So we just found out the tangent at this point, and it intersects the curve again at another point. So we are going to find out this point over here. Okay, how? We need to equate two things. Firstly, the equation of this tangent, the one on top, with my equation over here. So the equation of the curve can be written as y is equal to x plus 1 divided by x minus 1 whole square plus 2. Now if you do it correctly, what are you going to get if I input y over there? 3x plus 3 is equal to x plus 1 divided by x minus 1 whole square plus 2, or twice x plus 3 is equal to 1 divided by x minus 1 whole square plus 2. So I could simplify more. 2x plus 1 is equal to 1 divided by x minus 1 whole square, or twice x plus 1 times x minus 1 whole square is equal to 1. Is that what they asked us to find? Yeah, just a bit more. So twice x plus 1 times x minus 1 whole square minus 1 is equal to 0. Okay, twice x plus 1 times x minus 1 whole square minus 1 is equal to 0. So that is shown. Now verify that x equals to 3 by 2 satisfies this equation, and hence find the y coordinate of P. Okay. So if I input x equals to 3 by 2 over here, it should match. So 2 times 3 by 2 plus 1, then 3 by 2 minus 1 whole square minus 1 equals to 0. So after further simplification, it is 3 plus 1, which is 4, and 1.5 minus 1, which is half whole square minus 1 equals to 0. 4 times 1 by 4 minus 1 equals to 0, which is 1 minus 1 equals to 0, shown. So we just verified that x equals to 3 by 2 does fall in that equation. Now we know that y is equal to 3x plus 3. That also lies on the same point. So we can just input this 3 by 2 times 3 plus 3. So y is equal to 9 by 2 plus 3. How much is that? 9 by 2 plus 3 is 15 by 2 or 7.5. Y is equal to 15 by 2 or 7.5. 15 by 2, which is 7 whole 1 by 2, 7.5. Okay, that is our y coordinate. Okay, awesome. So we are done with question number 9. Now we have reached the end of the paper, question number 10. Let's do this. Find the maximum point of the curve in this diagram. So we have the equation of the graph given, which is y is equal to 9x minus 2x plus 1 to the power 3 by 2. So we have to differentiate it first. Dy by dx equals to 9 minus the power will come down. The power will decrease by 1. 3 by 2 minus 1 is half. And we have to differentiate the part inside times 2. So what are we getting? We get rid of this. So dy by dx equals to 9 minus 3 times 2x plus 1 to the power half. And to find out the maximum point, we need to equate it with 0. Okay, so 9 is equal to 3 times 2x plus 1 to the power half, or 2x plus 1 to the power half equals to 9 by 3, which is 3. If we square both sides, 2x plus 1 equals to 9, or 2x equals to 9 minus 1, which is 8, and x is finally equal to 4. Okay, now what? We just found that out. Now, coordinates of the maximum point. So we need to input it in y again. So y is equal to 9 times 4 minus 2 times 4 plus 1 to the power 3 by 2, which is y is equal to 36 minus 8 plus 1 to the power 3 by 2. So finally, y is equal to 36 minus 9 to the power 3 by 2. 9 to the power 3 by 2, and 36 minus answer, that is 9. Y is equal to 9. So my final answer is 4 comma 9. Those are my coordinates of the maximum point actually. I'll just check with the mark scheme. Yeah, that's fine. Moving on to the last two parts of the final question. Verify that line AB is a normal to the curve at A. So AB over here. Fine, we have the equation for dy by dx. Dy by dx is actually equal to this. Let me just copy that. Okay, so basically we know that dy by dx equals to this. So I need to find out the value of the gradient of the tangent at A. At A, right? It's mentioned at A. So I'm going to find out the value of the gradient of the tangent at A. How? I'm going to input x equals to 1.5 into dy by dx. X equals to 1.5. So dy by dx is equal to 9 minus 3 times 2 into 1.5, 3 by 2, plus 1 to the power half. So that is equal to 9 minus 3 times 3 plus 1 to the power half. So that is equal to 9 minus 3, 4 to the power half, which is root 4 is 2. So that is 9 minus 3 times 2 which is basically 9 minus 6, which is 3. Okay, so that's the gradient of the tangent. Now I want the gradient of this normal to be minus 1 by 3. So let's just check and find out the gradient of AB. MAB, the coordinates of A and B are 7.5, 3.5. 7.5, 3.5, and A is at 1.5, I think 1.5 and 5.5. Okay, let's see. So MAB equals to 3.5 minus 5.5 divided by 7.5 minus 1.5. Let's see. 3.5 minus 5.5 divided by 7.5 minus 1.5, which gives me an answer of minus 1 by 3. So since my dy by dx is 3, but the gradient of AB is minus 1 by 3, the tangent and this AB line, this AB is actually a normal to the curve AD. Okay, so how do we show that? 3 times minus 1 by 3 is actually equal to minus 1. Hence, AB is a normal at B. That is the exact wording. Okay, fine. Now find the area of the shaded region. How do we do this? So there are two things that we need to consider. One is the area under the curve, and the next one is the area under the line. Okay, so if you subtract the area of the line under the area of the curve itself for these particular limits, actually, okay, so what limits do we take? Actually, it is going to be this one and this one particularly. Okay, so I want to find out this area. This is a trapezium, and I want to subtract the whole area, the area under the curve, and then I'll get the area of the shaded region. Okay, so let's do this. You can do it. So let's find out the area of the trapezium first. Area of the trapezium, or this is the area, we could word it like this: area under the line AB is actually equal to, since it's a trapezium, it's half into A plus B into height. So what is the height actually? It's this, the height, which is 7.5 minus 1.5, which is 6. Okay, the height is 6, so half into 6. And what is A plus B? As you can see, one of the parallel lengths is 5.5 in length, and the other one is 3.5. So 3.5 plus 5.5. 3.5 plus 5.5. I don't have enough space. Wait 1 second. So that is 3.5 plus 5.5 times 6. So 3.5 plus 5.5 times 6 times 0.5, that is 27. That is the area under the line. Now let's find out the area under the curve. For these particular limits, what were the limits? It was 7.5 and 1.5. Okay, 7.5 and 1.5. And what is the equation of the curve? It is 9x minus 2x plus 1 to the power 3 by 2. 9x minus 2x plus 1 to the power 3 by 2 dx. Fine, let's do this last part. Okay, so this turns into 9x squared by 2, and this turns into, the power will increase now instead, to the power 5 by 2. This will go down 5 by 2 into 2, and the limits are 7.5 and 1.5. So we end up with 9 by 2x squared minus 1 by 5, 2x plus 1 to the power 5 by 2, limits 7.5, 1.5. Okay. Now if I input this inside properly, 9 by 2 times 7.5 square minus 1 by 5, 2 into 7.5 plus 1 to the power 5 by 2, minus 9 by 2 into 1.5 square plus 1 by 5 into, I need more space, got that, wait, so what was I saying, 1 by 5 times 2 into 1.5 plus 1. Okay, okay. I've missed a to the power 5 by 2 over here. There you go. Wait. To the power 5 by 2. Now let's do it. It's 9 by 2 into 7.5 whole square, which is 2025 by 8 minus 2 into 7.5 plus 1 to the power 5 by 2 into 1 by 5. That is 1024 by 5 minus 9 by 2 into 1.5 square. That is 81 by 8 plus 2 into 1.5 plus 1 to the power 5 by 2 times 1 by 5. That is 32 by 5. So let's simplify this. 2025 by 8 minus 1024 by 5 minus 81 by 8 plus 32 by 5. That is actually 44.6 or 223 by 5. Finally, what is the area of the shaded region? If we do write that, area of the shaded region, that is the curve minus the line, or 44.6 minus 27, that gives us a final answer of 17.6 units square. Okay, that is it for the day, guys. Hopefully you like the content and I've solved your problems. Overall, I'd say yeah, it was okay. Not a very easy paper, but comparatively much more easier than paper 1-1 and paper 1-2. So yeah, guys, that has been it. So if you did not understand anything, please do still comment below. I'll try to explain when I'm free. Also, do consider joining our Discord channel. I'll put a link in the description. And if you do like the content, please do consider supporting me on Patreon. It's patreon.com/CAI paper solved. Quick shout out to my top tier patrons for the month. We have Dewa, Luna, and Sean supporting me for this month. So please do consider supporting me there if you want to be featured at the end screen. Also, I'll link the paper for May June 2023 paper 1-1 up here, and the paper for May June 2023 paper 1-2 down here, and the playlist for math, pure math 1 up here. And remember to hit the subscribe button. See ya, guys. Bye bye.